Welcome to episode 40 of the What's Up podcast, recorded on the 2nd of October 2019. My name's Martin.
I'm Ali.
And I'm William.
Today we're going to cover a few news stories that have caught our eye in the press recently, and we're going to have our theme this week is going to be things that are hiding in plain sight. Let's start by the things that are furthest out and working our way in on these stories. So who's the furthest out this month?
Ooh, who is the furthest out? Is it me? It might be me. I think it's me.
I think it is you. It wasn't you, but it is you now.
It's quite fuzzy in the numbers. So,
yeah.
You know.
It's changing as we speak. It's changing right now. It will change during this podcast.
With fuzzy numbers, let's also go for fuzzy faces. And Ali, you start us off.
Excellent. So yeah, this story popped up on my feed because of a diagram, and it's a scaled diagram that appeared in a paper that has been put on the preprint server called Archive. So it's not necessarily published in a science journal yet, but hopefully it will be soon. And the diagram is fun because it's a scale model of a black hole. And it's about 9 centimeters across. It's just a solid black circle. And without getting too dense into the whole black hole physics thing, that is the size of a black hole you would get if you had a 5 Earth mass object and you crushed it down to be a black hole, which means nothing that we know of in physics can support it. It shrinks all the way down, turns into a black hole, and then you get this ring called the event horizon, beyond which everything else is completely dark. And if you cross that, you will fall onto said black hole.
So it's
quite dinky, and you can fit it on a piece of A4 paper.
The scale model or scale thing is a 1-to-1 scale.
Yes.
Beautiful.
Only if you print it at A4, though, which I don't think it specifies.
Well, and that also scares me because, different printers, different settings,
God, yeah,
plus
that black hole,
a couple
it's a
millimeters.
lot bigger, yeah.
But it was kind of fun because I don't remember that happening before, and clearly a bunch of Twitter people that I follow were also enjoying this. Just going, that's an awesome idea. Why didn't we think of this before? And the reason they have it is actually got nothing to do with sort of black hole physics. It's more to do with
just did it for fun.
Well, it's the hiding in plain sight thing, and it's really interesting, and it's connected to the Planet 9 story, which we haven't really talked about for a while. It's like a mystery. It's like a murder mystery. There's stuff happening, and we need to explain it. And so I've sort of dived down the rabbit hole a little bit. So I guess quick summary of Planet 9 is that by looking at how many weird things there are out in the very distant solar system, so stuff beyond the orbit of Neptune, and we found quite a few of these things.
Yes,
and
Pluto.
There's loads of tiny little things, but there's quite a few.
Planet 9 is
things.
Pluto.
Shut up. Pluto is still officially demoted, so Planet 9 would be the next chunky planet. So Pluto's not very massive. It's less than 1% the mass of the Earth. Not even something like 0.2 of a percent of the mass.
It's a
of the
full
Earth.
stop of a black hole.
Tiddler.
It's nothing.
So Pluto doesn't count, but there might be something chunky lurking out there, and this is because this is quite recent, so sort of 2016, people started to get a handle on the orbits of some of these trans-Neptunian things, which are small and icy, and on weirdly aligned orbital paths. So their orbital planes are slightly aligned, and they all come towards their closest point of their orbit on roughly the same side of our solar system, which is weird, and by chance this shouldn't happen. And there's a few different observables here, and they've been sort of piling up a little bit, so it's not like a smoking gun. There has to be Planet 9 out there. But the best explanation right now of why these things are weirdly aligned is that maybe, just maybe, there's something maybe 5 times more massive than the Earth, maybe 10 times more massive, lurking very far away. So Neptune's 30 AU, something like that from the sun, astronomical units, 8 minutes at the speed of light. This thing is around about 400 to 800 astronomical units, and it's currently on the furthest away part of its orbit, if it exists, which is making it really hard to see.
Presumably that orbit's incredibly long, so it wouldn't come near us again.
Yeah, the periods are something ridiculous. I mean, even for some of these trans-Neptunian things, you're talking thousands of years orbital periods, and for the Planet 9 itself, it's probably even longer than that.
So just to understand, so it's a highly elliptical orbit, so when it's trans-Neptune, is it actually coming in within Neptune's orbit at some point within its...
it's not crazy elliptical, but it's definitely elliptical, so it has a near point and a far point, and it gets into not much closer than... I can't remember now what its closest approach distance is.
Closer than Neptune?
Yeah, semi-major axis.
The trans Neptune is included in the name.
So it'll be way further out than Neptune.
Yeah,
so
most of the time. Yeah.
Yeah, but it's even though it's relatively light, still 5 Earth masses is fairly chunky compared to how light
It's pretty
Pluto
exciting.
and it's enough, even though it's remote, to just slightly nudge some of these things over time. But what's weird is that if you didn't have Planet 9 and you just waited, these random alignments of these trans-Neptunian things that we're studying should fall apart over time. So the fact that they're together means there's something out there helping to keep them and sort of shepherding them together. And all you need to do that is another thing out there somewhere. And it's kind of fun. It's really interesting because it's kind of how we found Neptune in the first place. It was just paying attention to Uranus. I didn't make a Uranus joke, you'll know. And then really paying attention to it. Sort of. Shut up. So really paying attention to it to the point where it's so precise, its positions on the sky, that you can see it slightly wandering ever so slightly not where you'd expect it to. But then when you factor in the gravity from Neptune, it starts to explain the observations not matching up to exactly what you thought. And this is where the numbers get crazy because you have to start running simulations with lots of assumptions about how much mass there is out there and how many perturbing objects there are. And the 8 chunky planets that we know of are obviously the biggest influencers of stuff in the solar system. And it doesn't guarantee there's an object out there. At one point, we thought there was a planet called Vulcan, which orbited inside the orbit of Mercury. But it turns out you just need a bit of Einstein physics to explain why Mercury's orbit is weird. So it doesn't necessarily mean there has to be a planet out there. And this is where the scale model of a black hole comes in. So it turns out that if you want an exotic solution for what this thing could be, it doesn't have to be a planet. Now, I should state for the record that we haven't found this thing yet. We haven't found an obvious smoking gun object out there, and that's annoyingly because a few different reasons. One is it's very faint, so it's not going to be very obvious in any of our surveys right now. But some people are literally going out and looking for this thing. And in the simulations, there are orbital path predictions for where this thing should be. One of the other reasons this is annoying is that orbital path is kind of aligned with where the galactic plane is. And if you do survey science, you hate observing in the galactic plane because if you're looking for stuff in the solar system, you've got the rest of the galaxy popping up objects all over the place and you're looking for something small and faint in amongst all this crowd. So that causes issues. So it's possible we've not just seen it yet, and it may happen within the next 10 years that we get good enough with our surveys that we can say whether or not for sure there is another thing out there. But one excuse could be that it's not actually a planet at all, and it's a little dinky black hole, and literally a dinky black hole. So a black hole the size of planet Earth, or the mass of planet Earth, shouldn't really exist. And this is where it gets even more mind-bending, because the way that we make black holes these days are you wait for a star to go supernova, and the star is sufficiently massive that you get a black hole that's more than about 1.5 times the mass of the sun. That's a really massive black hole. And that's a confident path to getting a black hole that we're fairly certain of. But there's also a very slight possibility that you can have a primordial black hole. Have you heard of primordial black holes before?
I have heard the term.
PBH for short. PBH. It turns out that in the very, very, very early universe, and I don't know enough about the physics, so I'm going to shut up about this real soon, but the conditions are right, and you can get dense regions that allow you to create a black hole from scratch. And they don't have to be nearly as massive as these stellar mass ones or the very huge ones in the middle of galaxies, but they can be the seeds that then become these more massive things. So there can still be a population of these things floating around out there, but because they're so low mass, it's very hard to say for sure that they're out there at all. And because you can't see these black holes unless they're feeding, which they're not, they're just dark against the sky, it's really hard to see any obvious sign of them being out there. So there's one of the reasons this black hole paper came out was because there's a little hint of a signal that there might be a population of these objects out in the Milky Way, and in which case we may have one hiding in our very distant solar system. It's quite fun, but at the moment there's just not enough numbers to say for sure. Planet 9's still looking more planety. The whole thing's been kind of fun, and it opens up all kinds of different rabbit holes. So if you want to take a trip with us down any particular one, let me know.
It's a kind of worrying solution to the problem, isn't it? So they can't find it, so you're postulating something which may or may not exist, which you probably can't see, which does sound a little bit kind of, you can't prove me wrong territory.
I mean, there's an entire field of astronomy looking at dark matter and dark energy, which is pretty much exactly what you've just said.
No.
Well, there is a way you could potentially search for this.
I want to take that up. But yeah.
It's partly
To the
testing,
pub.
but
So again, it sort of ties into our surveys because there's a survey called it's OGLE for short, but it's the Observational Gravitational Lensing Experiment, and they have a telescope that's designed to sit and stare at the sky for as long as it can and look for little spikes in brightness of objects, and some of those spikes get caused by lens objects moving in front of more distant things, and you get a little bump in the light curve. But the speed of that event tells you about the mass of the thing that just did the lensing, and it's all quite cool in Einsteinian physics where you're talking about light getting bent by the gravity of these things. And they were the ones that had reported a slight preponderance of things that are incredibly rapid, which means the mass of the lens is really small. So it could be free-floating planets, or it could be planet mass black holes as well. And there's not really a way of saying for sure in your numbers. But what you can do, there is an observational thing you can do for looking for these black holes, is that what we know about dark matter, it's possible that dark matter particles might smack into one another, very rarely, and they call that self-annihilation, but it might actually create a little gamma ray photon coming from that event, and you can actually look for those gamma rays as a little sign that something fun just happened with dark matter particles. But because dark matter particles are weird and they don't like interacting with anything, this is still quite speculative as well, but it does sort of work on paper. So there are a couple of ways you could try and rule this out, but I think right now it's more about ruling out where Planet 9 is hiding. And right now there's plenty of room for it to be hiding. I think, 5 solar masses is not huge and it's not going to be bright at 600 AU.
I went down this rabbit hole at some point as well, because the Planet 9 rabbit hole is fun. But I'm sure when I was reading, there was some suspicion is a strong word, but questioning about as you're saying, this thing is looking at trans-Neptune objects, the way they're being shepherded. What I was reading was arguing that there's an observational bias towards the things they found, which appear to be shepherded. That they're looking for things in that region of the sky, so they keep finding things in that region of the sky and say, oh, look, there's an overdensity of things in the region of the sky we're already staring at. Now, I was looking at this quite a long time ago. Maybe that has been sort of lifted, that suspicion.
You might be right, and I think I saw a paragraph about that in the review paper I just digested.
Right.
And it said something along the lines of, that is true because you're looking in certain regions of the sky. So, for example, if you're following the ecliptic plane of the solar system, that's a good place to look for solar system objects. It should be on both sides, so you should have a spike in one direction and a spike in another direction. And you only see the spike in one direction. And if it was completely random, that should be about the same in both ways. So I think they were saying that helps to rule out that as a spurious thing. Right. Doesn't mean it's not. I mean, even the review paper was sort of said there's still a very small chance, but they think it's less than 1% that it's just random.
No, I mean, and it's a good group doing it who've got pedigree of predicting and finding other things before. And I think didn't they find somewhere like, was it Make or some of these sort of other dwarf planets, I'm sure, were from the same group who are really pushing the Planet 9 angle. So it's, they've kind of gone, oh, there should be something over here. Oh, look, there is. On a smaller scale, because it's slightly easier to find some of these because they're smaller but nearer. So I'm not massively questioning them, but it's just
the fact that you can be so good at your job, you can look at the orbit of Saturn and rule out certain masses because Saturn doesn't get wobbled as much as it should. Because Cassini's been in orbit around Saturn for a long time, so that can give you a really accurate bit of orbital information for the planet because you've got a signal emitting thing around it. And if Planet 9 was out there and was more massive, then you'd see that. You would see Saturn wander slightly in the direction of this thing more than it should. So they can rule out certain masses just by looking at one of the other planets in the solar system. I find that really cool. But they were also saying it gets a bit noisy because as you're going to lower and lower masses and further distances, you could potentially have a whole bunch of leftover mass. I think there's about 1 Earth mass of stuff in the Kuiper belt in total. But if you don't know exactly where that is or how it's distributed, that can also affect your numbers. So it can melt the brain. But it's the fact that the way these things get talked about, it's Planet 9 is lurking out there, like some predator waiting to jump on us. But we're never going to see it in our lifetimes. But it would be fun to at least get a hint that it was there. But it's not like it's going to show up and destroy the Earth or anything.
Things that have just shown about the blue, though, brings us nicely onto our next story.
Oh, you?
Indeed. And
even if it is currently lurking behind the sun.
it's sort of it's hiding in plain sight, science on. Yes, this is our second possible, nearly confirmed interstellar interloper. So there was much excitement a couple of years ago when Oumuamua came whizzing through the cigar-shaped asteroid, which came through the solar system at such speed and at such a odd angle that there was no plausible way that the object could have originated within our solar system. And it seems to be that there's another good candidate showing similar behavior, which is quite exciting. I mean, it's interesting you were just saying about the Kuiper Belt, the amount of mass in the Kuiper Belt. It's worth saying that there is the Oort cloud is postulated as a large cloud of material left over from the formation of the solar system, lying way out beyond the Kuiper Belt. And there's a few objects whose orbital properties seem to match up with that. Suggests that there's something, there could be a big reservoir of things out there, because we found a few of them. They'd be quite hard to find, therefore we think there are lots of them. In theory, something like that could wander in occasionally, and as it did, and the Oort cloud I don't think is necessarily meant to be on such a sort of disk like the Kuiper Belt. It could come into the solar system at quite an angle. It's more of a kind of sphere of stuff. It's theoretical. We don't know it's there, and something I should stress, but it's possible there's that body, a reservoir from which you could get an object coming into the solar system at an angle. When I say an angle, I mean most of the planets, as Ali was saying, most of the planets and a lot of the comets and a lot of the things we see in the solar system are all sort of on a plane. So moving around on a tabletop effectively, and something suddenly comes whizzing in from way above the table and disappears down through the table and out the other side. That's a bit odd, but it could come from the Oort cloud, something like that. But the velocity of this is sufficiently high that it's unlikely that it could have accelerated that speed just coming from the Oort cloud. If it had been sitting stably in the Oort cloud for a long time, got nudged and then fell in, the free fall time and speed it would have reached seems too much for it to be just merrily one of our body from our own solar system. So hey, it's quite exciting. I think there is still a little bit of debate about this. It's not confirmed.
But you think it's quite likely?
Yeah, it does seem pretty likely.
Did I hear that this one's more comety than Oumuamua?
Yeah, so this is one of the exciting things. So Oumuamua was pretty much just a chunk of rock / spaceship. But
depending who you believe.
Yeah, but it seemed to be pretty much a chunk of rock. I think there was a little bit of a hint of outgassing, which some people tried to claim, but I think basically it's just a rock. Whereas this thing seems to be much more of a comet. So a comet, big ball of ice, effectively. Rosetta 67P.
Churyumov-Gerasimenko.
That's the one. The icy things, which when they come in towards the sun, melt because the sun is evaporating the ices on the outer layers. Incidentally, there's rocky body in there. It's not just purely ice, but primarily ice. And so you get this sort of outgassing. The thing appears to become really large on the sky because there's this huge cloud of melted or evaporated debris around it. And some of those get left behind. That's our meteor showers we see, because you get these trails of rubbish left behind by them. But the exciting thing is about an interstellar comet is that, unlike Oumuamua, which all we can see was reflected light coming off. All we can see was reflected light coming off the surface of that rock. The cometary body starts to outgas as it melts, as it comes in. And you can suddenly potentially sample that with spectroscopy and get a measurement of a sort of a body from another solar system. What's the composition of a comet in another solar system, which is pretty damn cool. So far, they have shown that it is got... I've got to look at my piece of paper. Hang on a second.
You brought a piece of paper?
I've got a piece of paper here.
We're allowed to bring pieces of paper?
Cyanogen, which is a molecule of 2 carbon atoms and 2 nitrogen atoms, has been apparently detected in it, which sounds really exciting, but apparently is actually very common in comets. But actually, any result is exciting, because if you find something which has got unobtainium in it, oh my god, that's amazing. There's a new type of solar system out there which is fundamentally different to ours. But something which says, actually the composition of the comet is exactly the same as our sort of comets and behaves in a similar way, that's pretty damn cool as well, because it shows that our system is not particularly special. Which,
because it comes back down to one of the sort of, I'm going to say as a standard mantra in astronomy, which is if you find one of them, it's strange. If you find 2 of them, it's everywhere.
Yeah. Exactly. Yeah. So if the first cometary body, which we happen to manage to analyze from another system, looks exactly like ours, the chances, therefore, all systems being fundamentally different has gone down a lot.
Yeah. It's still pretty exciting. Is it getting brighter?
Yes, so that's the good thing. I mean, it's currently, as you said, it's on the other side of the sun, so it's a little bit hard to do this analysis at the moment. But as we move around the sun, and also as it comes in, it's getting. This is why we debated where it is. It's coming into the solar system at very high speed, but it actually only gets as close to the sun as sort of just outside Mars's orbit. So it's not getting that close, and really, it's just flying by, and it's kind of orbital. What words I was using there? Its orbit's only getting sort of diverted a little bit by the sun.
It's not coming in too close.
No, so it's not like it's
did like a little
swinging
hairpin turn, didn't it?
It's just kind of whizzing by and getting a little bend in its orbit. But at its closest point in middle of December, it should be outgassing quite a bit, and we might manage to get a much more, A, it's going to be easier to observe because it's not near the sun, and B, it'll be brighter. So you might get much better measurements of the composition of this thing, which is really cool.
I forgot to check with Colin. Remember, he's got the Comet Interceptor mission. Would this one have been a viable target if they'd
don't know.
the thing? I have a suspicion it's moving too fast for them to catch up to it.
I think so, and I think also the orbital plane would be a problem. That the Comet Interceptor will be sitting in the plane of the table, and this thing is whizzing by just so you'd have to kind of make a handbrake turn in three-dimensional space.
Sorry to bring up Planet 9 again, but that's one of the possible origin stories for Planet 9 is it could have wandered in from somewhere else and actually slowed down and parked just because of interactions with other things. So this could be more distant stars. It was a much more crowded neighborhood back then, so you can have influence from stars and potentially knock Oort cloud stuff on us as well. Or it could have formed in situ and then been sort of lifted up to where it is. So there's a few different competing ideas for if it's real, how do you make it? But one of them is to grab one from somewhere.
Yeah, nick somebody else's planet. I mean, it's an interesting area. There's been some evidence and there's been some observations of lone planets, haven't there?
Free floating planets,
which have lost their star, which maybe have been flung out after some supernova ejection, or more likely probably a planetary nebula kind of point, at which a star's falling apart, the orbital system becomes unbound, and a planet just drifts off into space.
I read in that review paper, they said something like our solar system was potentially capable of making 5 icy giants. So it's possible we've lost a couple as well. I think they think there was enough material around at the time to help make a couple more. But it looks like the current theory is that our giants started further in and then migrated out, and a whole bunch of stuff might have got flung around at that point. So you could have maybe lost one then. Yeah. Maybe explains why Uranus is on its side too.
It's also interesting to think that we've now seen one, we now think 2 of these interlopers in fairly quick succession. Now, does that suggest they're a new thing, or is it more just that we're now starting to get good enough to spot them? And if so, is there a lot of this stuff going on?
Yeah, latter, I think. I think that you need to, these things are faint, and you need to be surveying the whole sky all the time to do it. Now, we are doing that, and we have been doing that for a long time, primarily because of things like asteroids and etc., which might come whizzing in and hit us. But our telescopes are getting better. They're able to detect fainter objects. And also I think some degree the algorithms which pick out the needles from the haystacks are improving. So I think that's part of the reason why a couple of them seem to pop up in quick succession. I don't think there's anything special about the last couple of years. And it's quite possible there are others. Say this object is coming in near to Mars, which is still quite a long way away, but hell, that's tiny in comparison to the size of the solar system, the distances Ali's talking about out to Neptune, etc. You might get interlopers which are slightly bent off their course, pulled in towards the sun, but don't get half as close as that, but are still whizzing through our solar system. So there's probably loads of them. We'll just find more as we get better telescopes, which is pretty cool, really. It paints a sort of picture of a much more dynamic galaxy, doesn't it, with these chunks of rock whizzing around. And I suppose if you really want to get sort of into the sort of, it's not science fiction, but I think it's quite an exciting side of it. And think about ice giants as well, or us donating ice giants. The question about life is, if life can survive on these things, then if we do live in a dynamic galaxy in which rocks or comets are getting flung around and are whizzing about merrily between different solar systems, well, if some of them are carrying life with them, then life should, in theory, extend quite quickly across the entire galaxy, which is
It feels a bit
That's very
unhygienic to me, one star cluster sneezes and a bunch of planets go flying all over the place.
Well, we know we've got life in our solar system, or at least at some point we must have the building blocks for said life. What point, if say we had gas giants, which we lost, or if we've lost any planets in the formation process of our planetary system, was there life in any of those before it got lost? I suppose this comes back to, currently we've got one data point. Maybe we're amazingly unique.
Well, they would have got flung out when the solar system was like really young. So the odds
probably true.
But then if you brought it with you from somewhere else,
If you've got comets, asteroids, that kind of stuff. As a great man once said, life finds a way.
So I think one of the most exciting things we could do, other than gold blooming, is to maybe find like space moss around an exoplanet. I think finding extra stuff in the solar system would be incredibly exciting. Bottom of Europa's ocean or something. But finding it around another star system that potentially we've never interacted with, just space moss. But then you could say there's life all over the place, which would be kind of nice. 0, 1, lots.
Okay, so we're going to pull it right down to earth now with something that's kind of hiding in plain sight. Not particularly hiding, given it was announced quite triumphantly a few days ago. There was a big SpaceX announcement about the progress they're making on their spaceship, or their starship, I should say.
I missed it. Was it good?
I didn't actually watch it live, but I've caught up on it since then. And it's, so one thing to point out is this is, apart from sort of being a general publicity thing about, the work they're doing and everything and some of the design changes they've made, it was also marking the 11th year since SpaceX launched their first orbital vehicle. So everything SpaceX have done has been in the last 11 years.
I feel a bit old now.
But that was like their first orbital flight of the Falcon 1, which you may remember. But it's only been 11 years, which is quite rapid where they've gone from that to now being one of the major sort of launcher companies. They've done loads of launchers, lots of different rockets. And now they're working on this Starship one.
And they called it like an unveiling for this one, is it?
Yeah. So they've essentially finished the external structure of the first prototype. I'm not quite sure what stage they're at.
So hang on,
can you do a summary of
Starship
what's
one.
the...
So this is H.G. Wellian crossed with 5-year-old's drawing of a rocket, what I can best describe it as, clad in silver. So this is their sort of Mars and Moon mission sized rocket, or moreover the Starship. So
it ain't small.
No, it's a big. It's 50 meters long and 9 meters in diameter, and it is designed to carry 100 people.
Whoa!
To
9 meters, is that's Saturn V width, is it, or is it wider?
I think it's getting up to that kind of thing. I'm not quite sure how it compares.
So sorry, this is the crew capsule. This is not the rocket. This is the.
Well, no, it's not the booster, but it is the second stage, you might say, and
it's
crew capsule. So this isn't like your short hop kind of thing. This is your, we're going to go land on the moon with 100 people and a butt ton of cargo and set up a base.
And this is like
yeah.
This is the top half, right?
Yeah,
because it's like a reusable second stage.
Pretty much, yeah. It's been compared to the space shuttle a few times. I think that's probably not a bad comparison because it does share some aesthetic similarities in the sense that it's got some fins on the back of it, and the way they get re-entry with this thing is by flying like a skydiver, was Elon Musk's description. You basically, because you've got a fairly big rocket or big ship here, you've got fins at the front, fins at the back, and you basically just plonk it hard into the atmosphere and come down on your long axis. So that's your drag is what slows you down, and then eventually you're going to flip up and sort of fire your boosters and stop and land vertically, because why wouldn't you?
How much does this weigh?
I don't actually know how much it weighs, but what I will point out is it's made of steel.
It's between 80 and 120 tons, but that's only because Scott Manley said there might have been a typo in the press release that was behind Elon.
Yeah, there was. He did point that out. There's something about one of the weights they showed was wrong.
But it's not light. I mean,
but that's not
big.
It's big, but that's not. 100 tons was Saturn V, wasn't it? 120 tons or something.
It could lift about 150 to the lower
150.
Orbit. Yeah. But then the shuttle was capable of about 100 tons, I think.
Yeah, and I think the Falcon Heavy is like 60 if it doesn't try to land again. But, so you're not also far off.
But then we're not talking payload here. We're talking the whole thing. So I don't know. because the whole plan was it was to refuel, wasn't it?
Yeah, so one of the things so there's a couple of key points about getting at orbital. One, you need a new rocket. There's
which doesn't exist.
Falcon, not Falcon Heavy. What was it called now?
the BFR.
Yeah, I think it's got a different name now, but
But I really liked the old.
and this is like just a chunky rocket. It's something like 37 Raptor engines on the bottom of it. It's just this array of Raptor booster engines all strapped together, and that thing launches and is reusable.
Please
and that's
using duct tape.
I've sort of the WD-40 is going to come back up in a second though. I can do WD-40. So that thing gets up orbital, and then you've got your Starship on top. You're going to have another Starship already up there.
Yeah.
The two of them back into each other. You dump all the fuel from the second one into the first one, or vice versa.
And then one of them comes back.
And then one of them comes back down to Earth. The other one goes off on its merry way to whatever other planetary body you want to go visit.
And at that point, you're fully fueled, so you don't need to get into orbit anymore. And
so there's a big thing. No one's ever tried doing orbital refueling before. So they'll be the first to do that once they get to that stage.
No one done that.
Interesting.
Because it's quite hard.
Yeah.
It's cryogenic fuel.
Yeah.
Yeah.
But one of the weird things, so when you said the thing looks like it's shiny silver because it's made out of stainless steel, which is not what you'd normally make rockets out of.
Why have they done that?
There's a whole list of really good reasons. Interestingly, as I was saying about the WD-40, this isn't the first time you've made a stainless steel rocket. Apparently, the Atlas rockets were all made out of stainless steel.
They were like balloons, which were like really thin.
Really thin.
Almost expanded when it was fully fueled.
Did expand. They were pressurized balloons basically of fuel.
Which is dangerous.
It went wrong. It did go wrong. I think they're using heavier composite, different manufacturing processes now, so it's not quite the same with the SpaceX one. But you get much better. So usually stainless steel is too heavy. So you've used aluminium to carbon composites and stuff to make it strong and light. The stainless steel, you get really good strength, but it's quite heavy. But you've got other advantages to it. One of them is actually heat dissipation. So stainless steel has much lower thermal conductivity than aluminium does. So if you're doing re-entry and you're getting hot on one side, with an aluminium thing, the whole thing gets hot very quickly. So the way to protect against that is by putting heat dissipating layers on top of it, which add to your weight. If you've got stainless steel, you can get away without doing that. It's much more robust and reusable. I think a key point about the Starship One is it's being built outside. It's not actually that hard to see. You can drive past the SpaceX factory and it's just sitting there being built outside because you don't need to protect the materials. Rusting and all that's far less of a risk.
But then I want to know if you've got like possums making a little house and you've got to keep it locked up tight at night to stop the animals.
It's actually called Noah's Ark.
A key difference between the Atlas and the SpaceX ones is I think the SpaceX ones are protecting the metal better. So in the Atlas ones, they didn't protect the metal, they didn't paint it to save weight, which meant that it kept rusting, which is why WD-40 was invented, which stands for Water Displacement Formula 40, because it dries moisture off materials. It's not actually designed as an oil or a lubricant. You really shouldn't use it as that. But it's designed to get rid of water and condensation. So you put that on metals. So WD-40 was invented for the Atlas rockets. Cool. Total aside. Anyway, you wanted duct tape, I gave you WD-40. So yeah, they've built it all outside, which means you don't have to build a big enclosure to build it in with cranes and all the rest. This is all been done with external standard cranes and cherry pickers and stuff. It's way cheaper than anything else. They were using carbon composites previously, and that was something like $12 or $20 a pound. Stainless steel is about $2.50, so it's vastly cheaper, and it's much more readily available. The carbon composites take a long time to produce and mold and all this kind of stuff. Stainless steel, you can buy big bulk sheets of.
I kind of like it. It almost feels like it's going steampunk.
Yeah,
a
it
bit
is,
more
yeah.
retro.
Retro rocket.
Is the model that they have right now? I'm assuming it's not flight ready. Is it just a sort of concept?
They have nothing to fly it with.
It's going to do a short hop, I think, so like a suborbital up and back down again.
But is this to allow them to refine the design and the aerodynamics, and then say, right, the design's working? Because it used to have 3 fins, and now it's only got 2 or something.
Yeah, they've done
it's
tweaks already.
Evolving.
They've gone from the carbon composite to the stainless steel. They've got a 6-month trajectory from now until orbital flight.
That's quite exciting.
Seriously? The orbital flight in 6 months?
That's what, yeah.
Doesn't that mean you need the bottom?
this was science fiction.
Well, they're working on that as well.
In 6 months?
Whoa. I suspect more like a year, 2 years. It's an aggressive timeline, let's put it that way.
Can you imagine? It's going to be exciting regardless.
They were talking a lot about the timeline for this Starship, less so about the rocket. So I think the two might be a bit of a thing we work. Because apparently there's like 37 Raptor engines that have to get built for the big rocket. Currently, SpaceX are making one rocket every 10 days. So at that production rate, assuming nothing else, you're not making enough engines. So the timelines didn't quite add up to me, but I don't know, maybe there's more plans on work.
Yeah, it'll be fun to see what happens. I'm not convinced it's going to be in orbit within 6 months.
I don't quite get the braking thing as well.
But then it's going to be
really
tricky,
work?
right? I mean, you're kind of, like you're saying, it's too big to build in a hangar, really. I mean, the VAB for Apollo was massive.
Yeah.
And the cost of just building that would probably be quite prohibitive compared to what SpaceX want to do. So building it in view of everybody and then wanting to test it before, I mean, there's something quite fun about how low tech it looks with just like all the weld joints between the seams. But then I mentioned, was it you I was talking to earlier, where welds can actually be quite structurally very sound. So if you do your welding right, it doesn't matter. And then it's kind of, when you zoom in on pictures of the Apollo spacecraft, you do see there's like little bumps and lumps where the welds are and the rivets are, and you realize it's not this pristine sci-fi, no seams visible kind of thing. It really is just lumps of metal that humans have stuck together. So
I mean, you think about the story about the ISS springing a leak, and it was filled up with 2-part epoxy and some duct tape. Space tech isn't that hard.
I'm willing this thing to fly. I would like to see it fly, but I'm just kind of
amazing. Yeah, it's crazy. The timelines, the complete changes. It's amazing work, and it really is. I think putting fire under other nations that want to do missions to the moon and to Mars and all that, because they're really pushing the boundaries here.
I've always wanted to see it. One of these, it's like a space shuttle on the top of a rocket, whereas the old space shuttle was strapped to the side.
Yeah,
this one's like big rocket core and then this huge shuttle-like re-entry vehicle on top. So that on its own is quite exciting because we've not flown like that before. Here we go.
Does it have windows?
I don't know if the current one does. They have plans for a very nice, like, panoramic forward dome view thing, as you can imagine with SpaceX. Sort of attractive aesthetic they go for.
Windows add mass, so I know you could get virtual windows and just have a wee fisheye camera at the front, and everyone uses the same camera, puts on a headset, and it's maybe a lot less.
Yeah, I saw someone talking about plane design for that. You'd build a supersonic plane; it'd be a lot easier if you just had no windows at all. Yeah. Much better. I need to go and look at this. I haven't looked at it at all. It sounds
I'm scared
brilliantly mad.
I'm scared to look into it more, though, because the more I read, the more I might be like, I'm not buying it. Or, I might just wait and be pleasantly surprised if
how does this land on the moon?
I'm not sure about the moon.
Because it doesn't have any braking.
For Mars, they had to come in an incredibly steep approach angle. They really got to come in, and it gets incredibly hot as a result.
Oh, that's good.
With the stainless steel, it's fine. Not sure it's good.
Steel melts at, a few thousand degrees?
They have put there. Well, so there's two things about that. One, they're putting special panels in particularly heat-sensitive areas. So they've got some sort of heat shielding there. And their plan for doing the Mars entry, where you get a lot hotter, is to let the spacecraft sweat. Now, what I mean by this is they're going to pump liquid methane around an outer shell on the spaceship, which has very small pores drilled in the outer layer. And as that gets hot, the methane expands and outgasses through those holes, which is basically the same thing as humans do with water on their skin to sweat. And that
But my sweat's not flammable.
Methane seemed a weird choice to me. But the reason for that is because you can get carbon dioxide and water from the Martian surface, which with some fancy chemistry you can turn into methane. So that's how you refuel
I've read this. You can do it you bring hydrogen with you, and you can suck carbon dioxide out there and make methane and oxygen to go home with.
And it's also
real time. To go home. Sorry.
No, to go home. And liquid methane is what fuels the rockets as well.
We might have to do a Mars special at some point.
This is 6 months. No, not to get to Mars. No. But
I think 6 months to be fully orbital.
Right, okay.
I think you have just hit the nail on the head, though. I mean, you've got to re-enter Earth's atmosphere and Mars's atmosphere, and those atmospheres are two completely different atmospheres.
Yeah,
it's like Mars is like 1% of Earth. So what works on Earth?
Yeah.
Does it really work on
Which is why you end up with sky cranes and crazy things they have to do to land the rovers.
Yeah.
And presumably if you could
I'm all for that too.
Oh, totally.
Landing on
unless I'm in it. I'm not landing on Mars in a sky crane. It still sounds like a drunken idea in above.
The fact that we're even having this conversation is kind of fun.
Yeah, it's true. You're right.
Like it's
I know. I feel like I'm sitting here being like, what about this? This doesn't work a little bit, but that is because
invariably,
cool.
when we bring up
It's
SpaceX, the three of us are like, really? We have to go and read into it and just go, I'm not sure.
I think it's also an interesting point that you've hit it on the head there. Because this has to go to Mars and back again, it's got 2 re-entries to do. So your traditional methods of sky cranes or single-use heat shields, ablative heat shields that burn up as you go in, they don't work anymore.
Right.
Because you've got to be able to reuse it. Hence this kind of methane sweat idea does make sense.
But if you could just cover it in stainless steel and therefore improve your properties, and why aren't NASA doing that already?
I think it's different. It's different problems.
Right.
They've taken a different tack.
Yeah.
And NASA, I know they're using they're using aluminium, but they're doing it in an ISO network structure, which means they're milling away a huge amount of the material to maintain strength versus mass, mass versus strength sort of side of things. It's not ISO, I can't remember what it's called. It's a certain, where you mill away material, you leave a certain structure behind made of triangles that's very strong, but you mill away 90% of your material. So it's incredibly expensive.
Mm-hmm.
So again, SpaceX are going for the avant-garde risky thing that's very cheap because that's what they're aiming for.
It's kind of
NASA have a
fun.
different approach.
Yeah, they've got the 2 completely different models.
Yeah,
Like
it's true.
NASA's one is, what do we need it to do? How do we get the mass down as low as possible? And then cost is not the most important factor there. It still matters.
Yeah.
You're not going to throw money at it, but at the same time, it's interesting that the first thing SpaceX are doing is going, how do we get it cheap and renewable and do it? So it'll be interesting to see if it works, I guess. Because I sense that if they get it to work, everyone else will be like, right, well, we'll be building stainless steel rockets too.
Let's see if by episode 50 of the podcast, we're at what stage they're at then.
We're going to have to go
What
to
are
a
we at
lunch
today?
and do a
40
live one.
today, 10 more.
10 months.
It'll be interesting.
Well, keep your ears out for that one. Thank you very much for listening.
Thanks all.
Bye.